first device we'll configure on this upper left-hand topology is the Snoop switch. So first we're going to give it its host name of Snoop switch, and then we'll enter line configuration mode to enter the logging synchronous command. The first command we'll enter is IP DHCP Snooping. This enables the feature, and we can verify this with the do show IP DHCP Snooping command. This way we stay in global configuration mode and we can check to see the feature is turned on. And there from the show output we can see that the feature is enabled. Once the feature is enabled, we have to specify the VLAN to do the DHCP snooping on. This particular switch, we're only going to be doing DHCP snooping on VLAN 1. But to demonstrate that you can do it on more than one VLAN, we're going to enter the IP DHCP snooping 15 and 1530. Now when we do the do show IP DHCP snooping command, it'll show us the VLANs that are participating in the DHCP snooping. And there we can see 1, 15, and 1530. Now we'll turn off DHCP snooping on VLAN 15 and 1530 just by using the up arrow and then putting the keyword no in front of the command. And so now DHCP snooping is only configured on VLAN 1. For this particular configuration, we're going to disable the insertion of option 82. Typically layer 3 switches, it's okay to have the insertion of option 82 enabled. But if you're going to be using your switch as a layer 2 switch, it should be disabled. So we achieve this with the no IP DHCP snooping information option command. Now when we do the do show IP DHCP snooping command, we can see that we've disabled the insertion of option 82. Option 82 has to do with the DHCP relay information, and it's recommended that for layer 2 switches you disable the switch, so we've gone ahead and disabled this feature. For the next part of the configuration, we're going to enter the error recovery cause DHCP-rate-limit command. And then we're also going to enter the error disable recovery interval 900 command. The 900 refers to seconds. What this means is the port will change its status to error disable if the port exceeds the DHCP rate limit. It will keep that status for 900 seconds, and then it will recover itself by re-enabling itself after the error. DHCP snooping by default has the port setting set to untrusted. Anytime you are connecting to the DHCP server or another switch, for example, you'll want to trust those ports. So for this example, we're going to trust the port connecting to branch 1 and expansion 1. So I use the interface range gigabit Ethernet 0/0-1 to get into the ports at the same time to enter the IP DHCP snooping trust command. So these are all the interfaces on the switch. So we want 0, 2, 0, 3, 1, 0, and 1, 1 to not be trusted. By default, they are not trusted, but we still need to set the DHCP limit rate on the interfaces. So we use the command interface range gigabit Ethernet 0/2-3, gigabit Ethernet 1/0-1 to get into all the untrusted interfaces at the same time. Then we're going to enter the IP DHCP Snooping limit rate 8 command. We'll use the show IP DHCP Snooping command to verify gigabit Ethernet 0/0 and 0/1 are trusted, their rate limits are unlimited. And now that we've set the rate limit to 8 on the untrusted ports, they will appear in the show output. If you leave the default commands, the untrusted ports do not appear in the show output. But by modifying the rate limit, that allows the show output to include the untrusted ports. So that concludes the DHCP snooping configuration. Next, we're going to move into the IP ARP inspection configuration. The first thing we'll do is enable the feature on the VLAN that we want it to be enabled on. In this particular example, we're only working with VLAN 1, so the command will be IP ARP inspection VLAN 1. Next, we'll enter the error disable recovery cause ARP inspection command. We've already set the interval, we've just added a second cause, which is the ARP-inspection. Next, we'll go into the interface configuration mode for our untrusted ports. We've already entered them one time during the DHCP snooping configuration, so we can just use the up arrow to get back to the interface range gigabit Ethernet 0/2-3, gigabit Ethernet 1/0-1 command. So now that we're back in the untrusted ports, we can use the IP ARP inspection limit rate 8 command. In this particular command, you can also have a burst interval setting, and we'll set that to 4. Now we use the show IP ARP inspection command to verify that the feature is enabled. Next, we use the show IP ARP inspection interface command to show us the trusted or untrusted state of the port. It also shows us our rate in packets per second, which we set to 8, and our burst interval, which is set to 4. Now we'll use the interface range gigabit Ethernet 0/0-1 command. We want these ports to be trusted because they're the ports that are connecting to the routers. Once we're in interface configuration mode, we enter the IP ARP inspection trust command. We'll use show IP ARP inspection interfaces again, and now we can see that the interfaces are trusted. So one more feature we'll talk about for the IP ARP inspection configuration is the validate command. The 3 options for the validate command are source MAC, destination MAC, and IP. First, we'll demonstrate how to turn on the IP ARP inspection validate for the source MAC. We enter the command and use the do show IP ARP inspection command. And here at the top, we can see that we've enabled source MAC validation. Now we'll enable destination MAC address validation. And when we do this, it disables the source MAC validation. So we'll use the show IP ARP inspection command to verify at the top of the show output here that we've enabled the validation by destination MAC address. Now what we'll do is we'll enable all 3 at the same time by entering the IP ARP inspection validate, source MAC, destination MAC, and IP. When we do this and look at the show put, we can now see that the 3 validations are enabled. So we're going to return the validation to the default setting, which is all of 3 features are disabled. So all we have to do is use the up arrow and then put the no command in front of the previous command. And now when we do the show command, we can see that the validations are now disabled. Now that we've completed the DHCP snooping and dynamic ARP inspection configuration on the snoop switch, we will now go into the branch 1 router, go into interface gigabit Ethernet 0/1 to give it the IP address 172.16.1.1, 255.255.255.0, followed by the no shutdown command to enable the interface. We're also going to have the interface participate in the OSPF routing protocol. So in interface gigabit Ethernet 0/1's configuration mode, we'll enter the IP OSPF 50 area 0 command. And so now the snoop switch network will participate in the OSPF routing protocol. Now we will focus on branch 1 and configuring it to be a DHCP server. We're going to use a /24 network, so we'll have 254 usable IP addresses. So the first part of the configuration, we enter the IP DHCP excluded addresses command to exclude the first 5 IP addresses in the range for our default gateway on branch 1 and the IP address for the interface on expansion 1. So now we have to define the DHCP pool. We do this with the IP DHCP pool command. We'll call this pool 1. Once we enter this command, we're in DHCP configuration mode. We have to have a domain name when we do DHCP configurations. So we enter the domain-name command, and then I used example.com for this particular example. Next, we need to define the DHCP pool. The subnet is this 172.16.1.0, and it will be a /24 network, so the dotted decimal notation for the subnet is 255.255.255.0. Now we enter the default router 172.16.1.1 command to define the default gateway for the snoop switch network. There's also a DNS-server command to set your DNS server IP address. And then this final lease command, which is in days. So this is a lease for 7 days. So we'll power on the desktops, and then they'll go through the DHCP DORA process, which is where the desktops will send out a discover message. The server responds with an offer message. The desktop responds back with a request. And then the DHCP server finishes with an acknowledge, and then that acknowledgement message will have the IP address for the desktop. So now that we have the PC powered on, we enter the IP adder command, and we can see that it pulled the 172.16.1.6 IP address. We excluded the first 5 IP addresses, so the first available address in the range was a 6, and that's why it chose the 6. We'll power on the other 2 desktops, and they'll start pulling their IP addresses from the server as well. Now what we'll do is we're going to define the expansion network's DHCP range. So before we do that, we exclude the addresses in the range with the IP DHCP excluded -addresses command. And then we're going to exclude only the 1 IP address for the default gateway. So now we'll define the DHC pool 2 with the IP DHC pool2 command. We'll use the domain-name command and use example.com for the domain name. Next, we'll define the network as 192.168.254.0, 255.255.255.0. Then we'll define the default router, which will be 192.168.254.1, followed by the DNS-server command. In this case, we'll use 8.8.8.8. And then finally, the lease command, which again is in days. So this IP address will be leased for 7 days. While the expansion 1 router finishes booting up, we'll go over to the Snoop switch. We're going to check out the DHCP Snooping binding table by using the show IP DHCP Snooping binding command. In the show output, we can see the 4 IP addresses that were assigned to our desktops by DHCP, their MAC addresses, and their port interfaces. So the DHCP snooping process builds this table, and then the dynamic ARP inspection configuration uses that information to either filter or allow ARP traffic. So now expansion 1 is booted up. We'll do our initial configurations. We'll give it the host name of expansion 1, and then get our logging asynchronous command in the line configuration mode to continue keeping our syslog messages looking clean during the configurations. So first we'll go into Gigabit Ethernet 0/1, configure the IP address 172.16.1.2, 255.255.255.0 command. We enable the interface with the no shutdown command. So this will give us connectivity between expansion 1 and branch 1. Now we'll go into interface configuration mode for Gigabit Ethernet 0/1 to configure the IP address that will act as the default gateway IP for the second expansion 1 network. So we enter the command IP address 192.168.254.1, 255.255.255.0. Then we enter the IP helper address 172.16.1.1 command, followed by the no shutdown command to enable the interface. For the initial configuration, we'll have a static route from branch 1 to the second DHCP network. We'll use the IP route 192.168.254.0, 255.255.255.0, 172.16.1.2 command to configure the static route. The 172.16.1.2 will be the expansion 1 Ethernet interface facing branch 1. The expansion 1 router will be using the IP-helper address command. So when it communicates with branch 1, it needs a static route back to the 192.168.254.0 network. When we move back into branch 1 and enter the show IP DHCP binding command, we see in the show output we've got our assigned leased IP addresses and the MAC address of the desktop that they were assigned to, and the date that they were assigned. We can also use the show IP DHCP pool command. The show output lets us know that 0 IP addresses have been leased on the expansion 1 network, the range and the current index. When we look at DHCP pool 1, there's been 6 IP addresses assigned and the current index is .12. So now what we'll do is we'll power on our desktops. They'll communicate with the expansion 1 router use the IP helper -address command to forward the DHCP messages to branch 1. The port on the Snoop switch facing expansion 1 is trusted, so the DHCP messages can flow from the expansion 1 router to the branch 1 router. Now that the desktops are powered on, we'll go into this desktop, look at its IP address, and we see that it's got the 192.168.254.4 IP address. And then we'll go back into the branch 1 router, enter the show IP DHCP binding command, and then we can see the 4 desktops have pulled their IP addresses, the 2, 3, 4, and 5. When we come back down to the show output and look at the current index, it's 192.168.254.6. So if we plugged in another PC, that would be the next IP address that would be assigned. This will finish our DHCP configurations for this upper left-hand corner topology. So what we are going to do next is advertise the 192.168.254.0 network on our OSPF Area 0 network. So first we're going to enter the interface configuration mode for Gigabit Ethernet 0/1, enter the IP OSPF 50 Area 0 command. Then we're also going to enter the interface configuration mode for Gigabit Ethernet 0/0 to enter the IP OSPF 50 Area 0 command. Now the neighbor adjacency forms with the 1.1.1.1 router, which is the branch 1 router. Next, we're going to change the router ID on expansion 1. So we'll enter router configuration mode with the router OSPF 50 command, and then use the router-ID 0.0.0.1 command. So we'll come back to the secure zone router, use the show IP route OSPF command, and now we can see our new 192.168.254.0/24 network is part of the routing table. And so now we can do some test pings. I'll ping one of the desktops on the 192.168.254 network, the .3 desktop, and we can see we got a response. Now we are going to move to this upper right-hand corner topology, turn on this security switch, and then we're going to copy the IP configuration from this VLAN 80 PC, and then paste it into our secure zone PCs. We're going to have them be static IP addresses, all in the same subnet. The subnet's going to be 10.77.77.0/29, which gives us 6 usable IP addresses in the subnet. The first IP address here will be 10.77.77.6 with its default gateway of 10.77.77.1. So now we can copy and paste this configuration into the next desktop, and then all we have to do is modify the IP address. So this telnet PC will be 10.77.77.5, and the IP PC will be 10.77.77.4. We'll go into the secure zone router, into interface Gigabit Ethernet, 0/1 to enter the default gateway IP address, which is going to be 10.77.77.1, and then 255.255.255.248. That is a /29 subnet, and that gives us 6 usable IP addresses. Now we enter the no shutdown command to enable the interface, followed by the IP-OSPF50 area 0 command to have the subnet participate in the OSPF routing protocol. So while these desktops are booting up, we're going to finish building the topology for the video. So we're going to move to the top of the topology, and we're going to drag out 2 switches that'll connect to core 1 and core 2. Then we're also going to drag out 2 routers. One will be hot swap router 1, the other will be hot swap router 2, to demonstrate some hot swap routing protocol concepts. And then another switch that will represent the internet service provider, which is our gateway to the internet. We label the top switch ISP, this first router HSRP1, and the second router HSRP2. Next, we're going to label this lower left-hand switch H switch 1, and then the switch on the right H switch 2. So we'll kind of straighten everything up here, and we'll make our connection from H switch 1 to core switch 1, and then H switch 2 to core switch 2. So we'll start making our last few connections of the video. So we'll connect HSRP1 to H switch 1, HSRP2 to H switch 2, and then we'll connect HSRP1 to HSRP2, connect HSRP1 to the ISP, and then connect HSRP2 to the ISP. And the last connection we need to make is between H switch 1 and H switch 2. And then we're going to plug in these 2 desktops off of the switch to act as our HSRP admin desktops. We'll go in and label this left side PC HSRP admin 1, and then the right side desktop HSRP admin 2. So we'll return to this right side secure zone topology. So now that everything's booted up, we're going to do some test pings. We're going to ping the 192.168.254.0 network. We'll ping the .3 PC, and we can see we got a response. So we have network connectivity all the way into our second DHCP network. Then we also have connectivity to the 192.168.8.0 network, which is in the lower left hand of the topology. So the secure zone PCs are able to touch every part of the network, except for the Area 51 part of the network. Now that we've established the connectivity throughout the network, we can start using access lists on the secure zone router to determine what traffic we want to flow into the network. Standard access control lists can only filter traffic by source IP address, so best practice dictates to put the standard access control list as close to the destination address as possible. In this particular case, it's going to be the secure zone router. So we use the command access list 8 deny host 192.168.8.100 to deny that host's traffic from entering this network. Standard access lists have an implicit deny statement at the end of them. What that means is it will deny all traffic by default. So we have to put in this access list 8 permit any statement to allow the other types of traffic on the network access to this network. Part of the ACL configuration process is setting the direction that the access list control list functions in. So what we'll do is enter gigabit Ethernet 0/0 to enter the IP access group command. We have to put in the name of the access list, which is 8, followed by direction. In this case, it's in because our gigabit Ethernet 0/0 port is on the left side of the router. To verify the ACL is working, we can do a test ping from the 192.168.8.100 PC. We'll try to ping one of the PCs on the secure zone, and the ping fails. So now we'll come over to a different PC, the 192.168.7.100, and then when we try to ping a PC in the secure zone, we're able to ping the desktops. So we'll generate an SSH login attempt from 192.168.8.100. The connection will be refused. So that's also an indication that our access list is working. Then we can also go to the router and use a show IP access lists command. And the show up lets us know how many matches have happened per condition since the access list has been implemented. Next, we're going to move into extended access lists. Best practice dictates for the extended access list that they be placed closest to the originating address as possible. So we're going to make an access list that's going to affect the DHCP networks. So first we use the command IP access-list command followed by the keyword extended. Then we put the name of our access list. In this case, it's block subnet list. Once we enter that command, we go into ACL configuration mode. Now we can enter the deny and permit statements. This first example will be denying all IP traffic from the 172.16.1.0 subnet to the 10.77.77.0 subnet. And we use the wildcard masks. So the /24 is the 0.0.0.255, and a /28 is the 0.0.0.15. The subnet is a /29, so this will block additional IP addresses if there's ever expansion in the future. Just like with standard access lists, extended access lists have an implicit deny statement at the end of the access list by default. We have to use a permit IP any statement to allow the other types of traffic out into the rest of the network. So we enter the permit IP any command. to allow the other types of traffic. We have to configure the direction of the access list. So we enter the interface configuration mode for Gigabit Ethernet 0/0 to enter the IP access -group command. We put in the name of our access list and then the direction that we want the access list to operate in. In this case, it'll be out. Now we can do some testing to verify the ACL is working. So first we'll go into a PC on the DHCP Snooping network, and then we'll try to do a ping to the 10.77.77.0 network. So we go in and we ping 10.77.77.4, and we can see that we're not getting the response. And now we'll come over to the second DHCP network, which is at 192.168.254.0 network. And then when we ping the secure zone network, it succeeds because the access list is not denying traffic from that subnet, only the 172.16.0 network. We can also verify on the router by using the show IP access list command. We can see our block subnet list, access list with the permit and deny statements. And then we can see the matches from the 172.16.1.0 network that were denied, and then the matches for the other types of traffic that were allowed. We move back into the central router to configure a extended access list. This one is going to block the telnet traffic from PCs VLAN 10 through 80 to going to the secure zone. The other types of traffic the PCs generate will be allowed through. So we enter the access control list configuration mode by entering the IP access-list extended block telnet list command. This also names the extended access list. We start the command with deny TCP 192.168.0.0.0.255.255. What this does is any IP address that begins with 192.168 will be filtered. So all of these addresses, all of these subnets, even though they're different, the first two octets are the same. So by using the wildcard mask in this way, any IP addresses that match these 192.168 in their first two octets will be a match for the access control list. The next part of the command defines the destination subnet. In this case, it's the 10.77.77.0.0.0.15 network. This blocks additional IP addresses to the /29 network. That way, if there's ever expansion, we won't have to alter the access list. Then we use the EQ parameter, which represents equals, and then we enter the number 23, which represents the well-known port of 23, which is the port used when creating a socket for a telnet connection. And like with the other access control lists, we enter the permit IP any statement to allow the other types of traffic into the network. Before we apply the direction to the interface for the ACL, we're going to do some testing. For the Cisco modeling labs, when you want to telnet into the desktops, you have to go into super user mode. So you enter the sudo su command, followed by the password, which is Cisco, and then you have to enter the telnet d command. entering this command will allow us to telnet into this PC in the secure zone. We haven't applied our ACL in a direction yet, so the ACL is not turned on. So we'll test the telnet connection to make sure that it works. And here we can see that we were able to telnet into the 10.77.77.5 PC. So we'll exit from the telnet connection, and then we'll go back into the central router into interface gigabit Ethernet 0/0, and then we'll enter the command IP access -group, and then the name of our access list, which is block telnet list, followed by the keyword out to set the direction of the access list. So now we'll go back into the PCs and we'll try a secure shell connection. The secure shell connection will succeed because the access list is only blocking on port 23. Secure shell tries to make connections on port 22, so it will be allowed through. So when we try the SSH connection, we're able to get into the PC. And here we got into the 10.77.77.5 PC. But now on the PC that we were able to telnet earlier, we try to telnet, the connection is refused. We tried a second time, the connection is refused. So to verify everything, we go into the central router, do the show IP access list command, and we can see here we have the 2 matches for our 2 denied telnet attempts, and then all the other matches for the traffic that was allowed through. The last access list we'll configure is going to be on the expansion 1 router. It'll be identical to the telnet access control list, except for this one will be blocking the secure shell port of 22. So we start the configuration with the IP access -list extended block SSH list command. This allows us to enter ACL configuration mode, and it names the access control list. So we begin with the deny TCP 192.168.254.0.0.0.255 part of the command. This defines the source subnet, which is our 192.168.254.0 network. Next, we'll enter the destination subnet, which is 10.77.77.0.0.0.15. The wildcard mask for the secure zone would be 0.0.0.7, but we're planning for expansion in the future, so we use the next subnet mask up. This way we won't have to alter the access list if there is expansion. Then we use the EQ parameter, which represents equals, and then we enter the number 22, which is for the secure shell port. We also enter the permit IP any statement to allow the other types of traffic into the network. So again, before we apply the access list to the interface and its direction, we're going to do some testing. So the first test we're going to do is a secure shell connection to the PC 10.77.77.5. We can see the connection works and we are on the secure zone network. So now we'll exit from the connection. We'll go back into the expansion 1 router and we'll apply the ACL to the gigabit Ethernet interface 0/0. So in interface configuration mode, we enter the IP access -group block SSH list out command. I misspelled block list there, so I re-enter the command IP access -group block list out. And this will apply the ACL and its direction to the interface. So now when we go back into the PC that we were able to secure shell with earlier, we attempt to do the secure shell and the connection is refused. We try it again, the connection is refused. However, the other types of traffic are still allowed. So when we try to ping to the same IP address, the ping traffic is allowed through the access list. So now we go back into the expansion 1 router, do a show IP access list, and the show output will show us that we had 2 matches for blocked SSH attempts, and then the ping traffic, the 4 pings were allowed through. That's the last access control list we'll be configuring. Now we're going to move to the top part of the topology to configure these top 2 routers and the switches for the hot swap routing protocol.